Today I'm going to solve this problem here, which I previously solved before. I don't exactly remember when. So yeah, this is also another very popular problem. So if we go here to the companies, we see Amazon loves it, Apple loves it, Microsoft loves it, Facebook not so much, but they still kind of love it. Anyway, so yeah, so this is kind of like a classic problem. It's also array-based or string-based, right? So the problem statement is just one sentence, which is always very good. So it says, given a string, find the length of the longest substring without repeating characters, right? And this gives us the definition of what a substring is, in case that's confusing. So a substring is a contiguous, non-empty sequence of characters within a string, right? So for example, if we take this string, the substring will be, the valid substring could be B, right, because it's not empty, or BC, BB, right? So this is what a substring is. Or consequently, if this was either like an array of numbers, the same definition will apply. It won't be called, of course, a substring, but it will be called a subarray. Cool. So now if we see, for example, the first input, right, which is this one, and the output is 3, right, which is the longest substring without repeating characters, meaning that the longest substring without repeating characters that has been encountered in this string has 3 characters, right? And here the explanation is that the answer is ABC, right? So if we take a look here, we see that the substring ABC is highlighted, right? But if we, for example, have a larger substring, which A is duplicate, right? So A is appearing twice, so it will not be valid. And then in B, it's pretty clear, right, that it's only 1. So the only possible subsequence is this big, and so on and so forth. Okay. Okay. So the key to solving these types of problems that involve like finding the substring of a string, for example, or finding the subarray, well, of a string that meets some condition, and that condition is like the longest without repeating characters. So for example, if it's finding a subarray in an input array which satisfies a given condition. So all of these problems, like, we could solve it, of course, like in a brute force approach, but this will be always very slow because most commonly, like, the brute force approach will be an n squared time complexity, which will just run too slow, right, with these types of inputs, which are quite large. So a very common technique is called, to solve these kinds of problems, is called the sliding window technique. So if we Google, for example, sliding window algorithm, we can see, like, yeah, there's a bunch of stuff, right? Like, it's quite a popular topic for solving these types of algorithm puzzles. So it's a lot of information out there and diagrams and stuff like that. So yeah, I mean, this basically just repeats what I just said, maybe in a more detailed manner. But again, the important thing is that the technique helps to reduce time complexity compared to brute force methods, right? Yeah, so it works by linear sequences. It's mostly used, right, on arrays or strings. Or I believe, I'm not sure if also you can apply some of this to linked lists as well. I'm pretty sure you can. But I'm not sure if there's such problems in LeetCode. I'm not really aware. So let's go back to here. So I'm gonna open this Jamboard and kind of copy this over. So let's copy this string here. So I'm gonna just start drawing this out. So we have, right, the first string is character, and we have B, C, A, B, C, B, and B, right? So what we want to do is basically just check, as kind of what we did before, which substring is the longest. So for example, this substring here has one character, and then we will check that the other one, this B, has two unique characters, and then the next substring will be ABC, has 3. Let me move this thing out of the way, and then we will go to this thing here, ABCA, but of course this is not, it no longer will be considered valid. So the length will still be, the longest length will still be 3, right? And then we will move to this one, ABCAB, but again, this one will be invalid, right? But let's say the whole gist of the sliding window technique to apply to this problem is that we will basically start with 2 pointers, right? That will basically represent the, so to speak, like the 2 corners of the sliding window. So usually they will start at the first index, right? Here, a start pointer and an end pointer, right? Will be initialized here. And then after that, we will basically start to shrink the sliding, the sliding window when we do not satisfy the given problem's condition, right? So for example, in this case, up until here, it will be a valid window, right? But then once we iterate to the next character, right, which is going to be A, then that condition will no longer be valid because A, it's also here, so it will be a duplicate character, right? So in that case, what we want to do is basically we will shrink, or not shrink, but slide, right? The window will slide through the array, and then in the next iteration, instead of taking account this first index where the A is, then the next iteration will basically have this, right? So we will shift an index, right, to the right, right? So this is going to be our start point, right? And by now our end point will be here, right? Our end index, right? So then our window will be basically made up of all these characters in between these two pointers, right? So the start index here will be 1, and then the end index here will be 3 in this case, right? Index 3. And we basically now repeat this. So so this substring is still 3, right? So 3 is still the record, right? And then we're gonna try to grow our window again. So we're gonna iterate to the next character, and it's the same problem, right? So we encountered 2 B's, B and B. So again, it's not like a valid substring. So the same operation is done. Now we're gonna increment our start pointer by 1, right? So now start pointer is gonna be 2 here, and so let me cross this out. And then after this, we're gonna start from here. and actually let me erase this part so it's not confusing, right, to here. Yeah, so the next iteration, of course, we will be having this here, right? So it's gonna be CABC, so again it's not valid, etc. So we're gonna repeat this process, right, until of course we reach the end of the array, right? Then we know we have finished iterating it, and then we should have found our longest substring. So there's two things we need to take into account, which is we need to keep track of the longest substring, right? So then we need a counter. And then we also need to store start pointer and end pointer, right? And the start pointer will have to increase when the window is not valid, right? So that's the main gist, right, of this algorithm. Okay, so to do that, we're gonna initialize our start pointer to be 0, and then our end pointer to be 0, and then we're gonna iterate through the string. So it's gonna be, I believe, len s, right? And then we're gonna say, okay, so we're gonna start to iterate here, and then we will also need a data structure to identify when we have had or encountered a repeating character. So for that, a good data structure to use will be a set, right? A hash set, because of course a set can only contain unique elements, right? So just by that, our space complexity, just for this solution, right? Space complexity will basically be big O of n, right? And then our time complexity will be also big O of n, right? Because we're only iterating once through the sequence. Okay, so let's do that. So let's call this char set, right? Character set. Have this here, and then we are going to also have a while loop. So while si is in the char set, we will remove the end, the character at the current start index, right? As we're seeing in the diagram, at the current where the current start index is, right? So we will remove it from the char set. So I think it should have the Python set a remove function. Otherwise, we can just wait until this thing errors out, and then after that, we're gonna increment, right, the start pointer by 1. Oops, right? So basically, this again. So this will do this operation, right, which is gonna remove this a from our set and increment our pointer by 1, right? So here it was incremented our start pointer by 1, right? And then after that, so basically this is invalid. So basically what this is doing is while then after that we are going to add the char set, right? So this are the character that we're currently at, right? So to the character set. And then there's another thing we need to do, which is store the longest count, right? So for that we can use basically the Python's max operator, which just returns the maximum value between two values, right? So then we're gonna say between the current longest count and the length of the character set. So that should be the only thing that we will need. And then of course, like if we just walk through this, right, throw ABC, so this will eventually reach ABC, right? This will be our set, and when A is reached, right, we will basically hit this while loop, right? Because A is already in our character set, and start pointer will be at 0, so we will remove this character, right, A, from our set. So then this will basically be AB at this moment, right? And then we will increment our start pointer by 1, so then this will be 1. And then after that we will add the current character, which in case is A. So now this will, oops, sorry, I made a mistake, it's BC. And then this will become BCA, right? When we add this, BCA. And then we will update the count, right? So it's still previously, like, you know, this is currently at 3. And then the longest count is obviously at 3. And then this is 3, so longest count won't change in this case, right? So I'm kind of like just recreating this scenario here quickly. And then we just return the result, longest count. Okay. Oops. And that should be it. So let's run it. Yep. So it passes all the test cases. I'm just gonna do another test case. Let's say one single character and one empty string. And yep, they are all pass as expected. So cool. So let's just submit it just in case. And there it is. Okay, nice. So yeah, this is one of the solutions. I think there might be a possibility where we don't need to use a set. Maybe we could do this in using space complexity of constant time, but perhaps I will try to find out how to do that and then explain the logic in another video. So this one is it for the moment.